If you've watched the last two videos about these problems, you should be pros at this point, so I'm going to fly through the beginning part here. If you need some help with the beginning part, I'd say go back and watch those last two videos. Really, the new part of this is going to be at the end when we simplify. So I'm going to start by drawing a right triangle in this quadrant. Between 180 and 270 is describing quadrant number 3. So let me draw my right triangle down in there. Always connect to the x-axis. There's my right angle. There's going to be theta. Next part of this is that I'm going to label my two sides. They've given me sine this time, and it's negative 2 over 7, or negative 2 over 7. I guess that sounds like the same thing. I was thinking something different in my head. Basically, I don't know which side's negative is what I was getting at. So my two sides, though, the opposite and the hypotenuse are 2 and 7. So my opposite side is going to be 2. My hypotenuse is going to be 7. But I do need to figure out which one of those sides is negative, because one of them definitely is. They're both not negative. There's two ways you can tell this. One thing I talked about in the last video was the hypotenuse is never, ever, ever going to be negative. So by process of elimination, then it must be a negative 2. However, you can also remember this. If any side is ever going down, that side's going to be negative. If any side is going to the left, which looks like we'll have that side would also be negative. All right, so then let's find our missing side. I'll call it x this time again. So x squared plus negative 2 squared, don't forget those parentheses, has to equal 7 squared with Pythagorean theorem. So x squared plus 4 equals 49. I'll subtract 4 from both sides, so x squared is equal to 45. And then when I take a square root, I don't want decimals. Oops, not squared anymore. I don't want decimals, so I'll leave it as the square root of 45. However, as I've been saying in the other videos, you do want to always try to break these down, and this can be simplified. So I'll show you how to do that, remind you how to do that, but I trust you all remember this. 45 can be written as 9 times 5. And then 9 can be written as 3 times 3. Remember, you're looking for primes, and then you're looking for pairs of primes. So there's a pair of 3s. They'll get to come outside. That 5, that single, will stay in. Oops. So 3 square root of 5. But then remember, sometimes you have to manually put on negative signs. And as we suggested a few moments ago, any side going to the left is going to be negative. So let's make sure that's a negative 3 root 5. All right, so let's finish this then. There's a little bit more to this one than the last couple I've had. I want to find the secant of theta. I hate working with the reciprocals, so in my head I'm thinking, well, secant's just the reciprocal of cosine. And I know cosine's the adjacent over the hypotenuse. So I guess this time I'm finding the hypotenuse over the adjacent side. So my hypotenuse was 7. We knew that from the beginning. The adjacent side is the one we just found, the negative 3 root 5. So it would be all great if we could be done at this point, but sadly we can't. Since we have a square root in the bottom, we also have to deal with that. So what we'll do, as we've always done, if there's any square root in the bottom, to get rid of it, just multiply the top and the bottom by that square root. Don't worry about the 3, that's going to be fine. When you do this, then 7 times the square root of 5 is just 7 square root of 5. On the bottom, you'll have a negative 3. And then square root of 5 times square root of 5 is just a regular 5. And so then if I finish that one, isn't this fun at the end here when they make you do this? 7 square root of 5 over just a negative 15. And so I guess I kind of lost the secant over there. But the secant of theta in the simplified version is equal to 7 square root of 5 over negative 15.